Okay. And I will pass it over to Jason.
Thank you. So as Courtney mentioned, my name is Jason Marshall. I'm the lab director at the Toxic Use Reduction Institute. I've been at Turi for a little over 25 years. One of the main things about Turi does is helps companies in Massachusetts and the surrounding areas find safer alternatives to hazardous chemicals. And for the lab, it's more around cleaning applications. And one of those focus areas, if you want to go to the next slide, has been the food and beverage sector. Obviously, you have to clean and sanitize the vats between batches. The chemicals that are used are to remove what's left behind and sanitize for the next step, so you don't have any cross contamination. Both of these steps can have potential for exposure to harmful chemicals, as well as releases to the environment. And this is normally a clean in place type of process where you're not taking things apart, putting them in another specified area for cleaning. It's the actual vessels that you're using. Unfortunately, many of the traditional cleaners that have been used are potentially can cause a lot of hazards to the workers, the potential for exposure. Being a clean in place type of process, there's less chance during the cleaning application. It's more about the preparation and adding the chemicals into the vat where things can go kind of off the rails a little bit. Next slide. So one of the things that you need to consider when you're looking for alternatives is, that not only the environmental, but the human health considerations. One of the reasons why the lab was set up was because it's great to find something that you think is safer for both you and the workers and the environment, but you still have to make sure that these products work. And so that's one of the things that the lab has been doing for 20, 30 years, has been cleaning, showing how well these greener products work compared to the traditional products. And then once you find something, you're gonna make sure that you can afford to make the switch to these chemistries. They're not all created equal. Some cost more, some cost less. There's also the regulatory and other safety considerations when you're making the selection. Okay. So as I had mentioned, we had worked several projects throughout the food and beverage sector. Most recently, we worked with breweries in Massachusetts. We kind of found out what they were typically using for cleaning applications, sanitizing chemicals. And so what we did is we selected a handful of chemistries that we thought would represent what you would find in a typical traditional cleaning product in the sanitizing chemistry. These are the 4 products that you see on here, the ones that they came to us based from the conversations with brewers in Massachusetts. It may not be specifically the one you're using, but if you go to the next slide, you'll see that we listed the active ingredients that were listed on the safety data sheet. So these may look more familiar than the product name. So you may see chemicals that oh yeah, I know that's in the product you're using. So this is kind of give you an idea of the overall assessment of what's out there, because there's hundreds of products we could go through and do assessments for, but this is kind of show you how the process would work. Next slide. So the way that the Turi lab goes through and assess for health and safety is a tool that we came up and made back in the early 90s. It started out being an Excel 95 version that we made available to people. So you can imagine how cumbersome and painful that was to use. So over the past 5 years or so, we have taken that, looked at all the endpoints that were generated back in the 90s, updated that to be more in line with the GHS system that's out there, Global Harmonized System. And so the website you see there is now an online tool that you can either do one of two things. You can go through and look for the almost 3,000 products we've assessed and added to the database. You can also use it to assess your own chemistries that you may be looking at to see how safe they would be compared to something else. And so the areas that this tool focuses on is the short-term and long-term effects, as well as what it does to aquatic life, as well as other problems with the environment and how long it stays in the environment. We look at atmospheric hazards as it a HAP, can it lead to acid rain? We look at the physical properties, as well as there's a couple of on the bottom of the slide you can't quite see, but it's the process factors as well as life cycle assessment. So looking at not only what the chemistries are, what type of equipment you're using it in, what type of exposures you may have to the workers, how much time is spent on a task, how much stress there is with working with these chemistries, and as well as what happens upstream, who has to make these, and what do you do with them when we have to dispose of them. So that's the life cycle assessment. Next. So this is a short version of what you would see from data collection. The resources that we use to do these assessments starts off with a safety data sheet. Luckily, safety data sheets have become much better in the past 4 or 5 years. I mean, I've done some assessments with safety data sheets from the early 90s, and you can't tell anything from it, but they've gotten better. But that's not to say that they have all the information you need. So on the website, there's other resources that you can use to try to help find more information about the effects and the endpoints that we're looking for. So what it ends up doing is we go through and we input the data that we collect, and there's a rubric that we relate the values to determine a low, medium, high, and a very high exposure or risk factors and health effects. So you can quickly look with the color coding we have here. The reds are not where you want to be. The oranges are not a little bit better, but not great. You want to be more towards the low and the mediums, the greens and the yellows if you can. And we understand that you're never going to find the perfect opportunity for perfect chemistry that's going to be all greens and still work and still cost what you can afford. So there's a balancing act that you have to go through and decide, is this product that we're looking at safer than the traditional products? So this table right here is a picture of the 4 that we said were representative of what's out there. As you can see, a couple of them have several reds of concern. If you go to the next slide, this is an example of some of the other chemistries that I think these came to me later on, I think actually from the project from Maine. And so you can see that these are some of the chemistries that they were using as well. So you can see there are some that are better, some that are worse. Go to the next slide, which should be the alternatives. You can see there's a chemistries that we identified for the project here in Massachusetts, what we were working on. These are the 4 cleaning chemistries that we came across, as well as disinfectant or sanitizer. You can see that the exposure potential, the health and safety, just by looking at the colors, you can see there's a lot less. There's actually no reds, but there's a lot less orange. And there's a good balance of yellows and greens. So you can see that these should meet the criteria for being a safer alternative. And so the next thing you would have to do is figure out how to validate that for performance. You go to the next slide. So this is more of the sanitizers. And so you can see that not the thing with sanitizers is they're designed to kill things. So there's some level of hazard associated with them. But like I said, the balancing act is finding ones that will be safer than what you're currently using. Next. This is a little hard to see on the screen, but what this did, this is the summary of the project that we did here in Massachusetts. You can see the first 3 columns there for the baseline cleaners, and then the next ones are the alternatives. So you can see that there's the overall ranking for the product, below, medium, high, very high. And what we also tried to pull out is the areas of most concern for each of the chemicals. So was it short-term human effects and long-term effects, as well as environmental, fate, and transport. So if there was no areas of concern, you can see that it says no categories. So that's kind of where you'd like to go. So, and there's also what we tried to do is we did lab testing based on soils that were from inside of the vats that would normally be cleaned. We tested them out on coupons. We were able to do soil removal rates. And you got an idea of, you can see where the baseline chemicals were, 90% removal and above. Some of the alternatives that we looked at, weren't as good, but would they be good enough? That's where piloting comes in. Once you figure out which chemistries you want to go to, you can then try it out on your equipment or batch size thing to see if it meets the level of what you need. And so we also tried to add in around, I had mentioned, how much does it cost comparatively? You can see that across the bottom that the traditional baseline chemistries, $600 to $1,000, which is a little bit less than most of the other alternatives. But the balancing act is not looking at just the purchase cost, but also what else do you have to deal with these chemicals? Is there a cost for disposal? Is there a cost for the PPE that you'd have to be wearing? Is there specific training that they wouldn't necessarily have with some of the alternatives? The next slide is the same idea, but around the sanitizing chemistries that we looked at. where we weren't able to do, we didn't do gravimetric analysis. We used the ATP swabs, which looks for biological materials. They're relative to the industry that you're working with. These 0s, 3s, and 10s wouldn't mean the same thing if you were looking at ATP swabs in, say, like a school classroom or a hospital. You have to set your baseline to determine where you need to be. So we did testings before and after to show where it started at and how low it went. I think what you see here is the lower the number that you'd have, the better sanitized the surface would be. It's only one of the alternatives was higher than the other ones that you can see the 0 to 10, but it didn't look like it was very consistent because it was 0s through 10. And again, it talks about the costs and of any equipment that you would need, as well as the actual chemistries themselves. Okay. So I know I just threw a lot at you there real quick, but it's important to identify what the safer alternatives are. You also want to make sure that they're going to work for your situation. You have to do, just because it worked in the lab setting isn't a guarantee that it's going to work for you. It gives you a better starting point, but you still do need to do piloting testing and looking at how well that integrates with what you're trying to do at your facility. I know that most of this is geared towards main facilities, but if you get stuck and you're looking for alternatives to validate how well things work, feel free to contact us and we can help try to figure out a way you could do something like that, either remotely or in conjunction with us at some point somehow. Next slide. I think that was, yep. So I know that one question did pop up. I know that these slides will be available. And like I said, if you have questions about what I talked about, if you want to have help on P2 Oasis training or anything like that, there are videos on the site that will help walk you through it. But we have found that usually the best way to do it is to send me an email, and if you have questions, I can walk you through it that way. It doesn't hurt to try it out on your own. If you get stuck, send us an email.
Great, thank you, Jason. And we're gonna toss it over to Peter Cook. And if you have any questions for Jason, save them to the end, and there will be time to ask them.
Okay, well, thanks, Jason. Thanks, Courtney. So I am gonna present a little bit on financial reasons to think about alternative cleaning chemicals. And this is a topic that I've talked about, oh gosh, for many years, but for different industry sectors, just because there's so many different chemicals in use out there all across different business sectors, a lot of which are a little bit more harsh and stronger than maybe what they need to be. But there are some financial implications for using chemicals that are considered to be more hazardous or more toxic. Just a couple of general reasons to start off with. Yeah, I mean, if you can reduce the amount of talking your business, the worker customer, working way before we started working closely with breweries, had to do with the boat building industry, and they were the boat builders were using chemicals that were considered pretty toxic, and when they realized that they were responsible for those as a waste from cradle all the way to different alternatives, but it also helped reduce the amount of exposure, potential exposure that the employees were experiencing. And so I think this might be a benefit to the brewery industry. It definitely improves the indoor air quality. Whether or not it can attract a sensitive or conscientious customer to the brewery, I don't know. That's a framing and a marketing initiative up to the brewery. But with some of our other work, such as hotels and restaurants and grocery stores, yeah, that it was definitely something that could be communicated to the community of customers and the community of employees as a benefit to, for the switch to less toxic alternatives. I'll talk a little bit about that at the end, but I'll just go in terms of like what it costs to fix, or if there is an issue of exposure or a spill. I'm going to talk a little bit about that in the coming up slides, because they can prove to be pretty costly And this is actually an insurance liability sort of issue that a brewery can potentially leverage to be more insurable. So if you go to the next slide, please, Courtney. I think you got to hit it one more time, because for some reason there was a duplicate. So we're coming up on 30 years pretty soon of having data that has to do with incidents of exposure to hazardous chemicals in Maine. And it's cool because when I started collecting this data, we were pretty much a state of 1 million people almost over 20 years ago. When I started looking at this, we're about 1.3 million, but you know, whatever. And like times I presented on this, I like to just sort of say like, look, for every 1 million people, this is what you're looking at. So over that almost 30 years, we're looking at over 6,000 workmen's compensation cases, which have to do with a reported incident of exposure to a toxic chemical. Breaks down to over 200 cases per year across all industries. This is not specific to any one industry. This is specific to all workmen's compensation cases in the state of Maine. Have to do with exposure to average cost is about $4,000. But it would be more, it would be a lot higher, but virtually almost most of the claims have no reported costs. But when they do have a cost, the average cost is about $35,000. And now that's not to the business, of course, that is to the insurance company. But if you can, you know, our line of thinking is that if you can reduce the amount of toxics in your business, and if you're having a hard time getting insured, or if you want to be, or even if you want to negotiate your rate, if you have less toxics on site than the average business does, I would say that makes you more insurable. And so you know, as a business owner, I would definitely be thinking along these lines when you're negotiating your insurance rates. The next slide, please. So yeah, about 675 incidents of exposure claims had payable benefits. That's a little over 10% of them. And when the benefits that were paid out exceeded $5,000, it actually the average cost was over $50,000. On the previous slide, we showed that the overall average cost was $35K, but the higher they get, the higher average amount of payout it is. These are all the statistics from the Maine Department of Labor. But I think that, you know, there is an associated cost with using chemicals that are considered to be more toxic or potentially more hazardous than other chemicals. And as a business owner, just really encourage folks to sort of figure out a way to communicate that both to, you know, whoever your insurer is, also to communicate to your employees if you're trying to make a reduction in toxics about what the benefit to them is and to the business. And then if it's even something that you want to talk to your customers about, you know, there is definitely a benefit, because depending on which market research firm that you look at, whether it's Nielsen or Cone Communications or Mintel, over the last 20 years, the amount of interest in green cleaning chemicals and less toxic alternatives from the consumers of businesses has been steadily and significantly increasing. From, I think when I started tracking it in about 20 years ago, it was probably in the high 50s to low 60 percentile. And now, no matter which market research firm you look at, it's up and over 75% of customers are interested in less toxic alternatives. And that's pretty much when they're bringing them home to their own house. But it does mean that could be a potential benefit to the business if you wanted to communicate what you're doing to take care of your employees or the customers while they're at the business. I did a webinar about a year ago for Green Biz, where I was talking to a lot of nonprofit organizations and about increasing the amount of green certified cleaning chemicals, whether it was Green Seal certification, Eco Logo, or Safer Choice. And even for the people that were in the business of encouraging less toxic alternatives, they all thought that the average number of people that would be interested in green cleaning chemicals was somewhere around 20%, which is basically 1/3 of what it actually is. So if the professionals in the NGO arena who are encouraging these chemicals are thinking that less people are actually interested in them, are that wrong? It just shows that there's a huge opportunity, because almost 3/4 of people are interested in being marketed that way. So there is a big opportunity there that breweries can, lean on more safer and less toxic alternatives. And it does become a marketing question for the business owner, how they want to communicate that. All right, next slide, please. This is just some more Department of Labor data in terms of like where all these numbers are coming from in terms of what it costs, and like why is the average cost $5,000 reported, just that insurance claims. So next slide, please. I think I'm stuck unless you can go to the next one. Courtney, which slide are you showing now? Because mine, oh, here we go. Okay. And so for the remainder of the time, I'm just going to talk a little bit about the New England Regional Certification Program. In Maine, where the New England Environmental Finance Center started this initiative. These are the breweries that we have started with in terms of like trying to track and measure and encourage more operational sustainability. These 6 breweries here are the first ones that really stepped up and said, yeah, I'd like to participate. We'll do what we can. And right now, we're trying to grow the program from these 6 to the rest of the breweries in Maine. The certification program is a program that is about tracking and documenting operational sustainability. It's not an awards program. We're not giving out the gold, silver, and bronze medal to anybody. We just want as many breweries thinking about the different ways that their business interacts with the environment as possible. So whether that's less toxic cleaning chemicals, or whether it's energy efficiency, waste reduction, water conservation, et cetera, even to the social side of sustainability when it comes to employees and the communities in which the businesses are in, how all that is documented in terms of like what they are doing to be more sustainable. So the New England Environmental Finance Center is been working specifically in Maine on this, working with the other states in the upcoming year through a grant that we received from the EPA. And a couple other regions in the country are also interested in replicating the arrangement that we've got up here with the different states and the breweries and the associations. So the New England EFC is going to be working with the EFCs in other regions for EPA. Region 3, which is based in Atlantic states, and Region 4, which is based in North Carolina, and does the best has really been generated in terms of how the program is being administered for breweries. And obviously in some of the other states, the brewery industry is also really interested in participating in a sustainability program. So they both match up quite well to start sort of replicating around the country. These 6 businesses that we've worked here within Maine are definitely the main leaders in terms of trying to be more sustainable. New Hampshire and Vermont have a history of working with breweries too, and they have their own set of leaders. If you go to the next slide, please, Courtney. But we're getting a lot of support from different organizations. And so we have a lot of support from the Maine Brewers Guild and Sean Sullivan. So we're very thankful for that. As I mentioned, the United States EPA is funding our efforts to bring more breweries into the program. The main DEP has the Environmental Leader Program, which we started the Environmental Leader Program with hotels way back in about 2002, and that's grown from hotels to restaurants, to grocery stores, and now breweries. And then the National BA, the National Brewers Association, has the benchmarking tool, which we're also helping our participant brewers do that as well, because that can help benchmark their progress over that tool that they have if they're an association member. And then the University of Southern Maine has a tourism and hospitality program, and the Muskie School of Public Service, which we're working with as well. Okay, next slide, please.
Thanks, Peter.
So yeah, with that, we're yeah.
I was going to say, we just want to pass it over to Jim now. Jim actually worked with us to try out one of the recommended products from Turi to use as a cleaner. And we did a couple trials with Jim. And so we're just going to let him say a few words before we get to questions about his experience with the trials and what he's using now.
Oh, hi. Yeah, thank you, everyone. We did the test on the alternative to our caustic cleaner that we use quite a bit, cleaning the fermenters. The first trial, I think, was about 80% as effective as what we're currently using. And then we tried it again with new recommendations from the company, and it was about 90%. So we've switched over to that for cleaning our fermenters between batches. What's nice about it is you don't have to worry about getting the chemical on you. It's not, because it's just not as toxic. It doesn't have really any odor at all, which is kind of nice. And it does just as good a job cleaning. And then when we rinse it down to drain, we don't have to worry about affecting the sewage system here in Portland area. So it was a really good experience working with Courtney and the university doing the testing on the less toxic cleaners.
Thanks, Jim. So now we just have time for some questions. We have like 15 minutes of time, so we're ahead of schedule. I'll stop sharing my screen, but I know there was one question in the chat specifically about costs and really the cost effectiveness. And I think Peter spoke a little bit about costs in terms of incidents, but I think all three of you might have something to say about cost and how you weigh the cost.
Yeah, the cost of the cleaner we switched to is I think it was about 25% more than what we're paying. We're buying it in, we started getting it in the quart size. We can get some 5-gallon bucket of it next. But just because it's so much safer and there's just less risk of injury I do most of the cleaning, or we have a couple people that help out, a couple part-time people that help in the back. Just the fact that it's safer and we don't have to worry about people being injured is worth the increase in the cost.
Yeah, and I'll agree with Jim that that's a great way to sort of think about it, because yeah, I mean, you may be insured and your insurance may cover you know, a little bit of an incident or a spill, but like when it becomes a legal liability to the business of having to cover somebody's medical costs, you know, that's definitely a liability that is on the business. So the more that you can reduce the toxics, the more you can reduce that potential liability. Any other
Jason?
questions?
Oh. Yep, Rob.
Hi there. I'm wondering if it's possible for Jim to actually mention what the alternative chemical he used was and/or where he sourced it.
Jim, do you want to answer that?
Yeah, I can't remember the name off the top of my head. I'm actually looking right now.
It's Surface Cleanse 930.
Yes, there you go.
Yes.
And I did the original order from that you sent me, the company.
International Products Corporation.
Yeah, and I got a couple from them, and I actually talked to our local chemical, and they're looking to see if they can get in larger quantities for me, because the quarts are kind of expensive.
Yeah. Thanks, Jim.
Great,
Luke, did you have a question?
Yeah, hi, thanks. This has been great. I'm just curious kind of about more the nuts and bolts of the actual cleaning process, kind of the size of tank you were cleaning, the time you, like the CIP process, I suppose, as well as storage. You can go into that a little bit, Jim.
Yeah, so we tested it on our 5-barrel fermenters, and we have our CIP cart for that. Mix it up the same as we would the other chemicals. It was a lower temperature that they recommended. I think it was like 140 degrees. Versus the other stuff we use is usually like 160 to 180. So it was definitely a little bit cooler, but it was the same basic process. We hit the tank with a little hot water to warm it up. Get the CIP cart up the temp, put the chemical in, and then ran it for, I think it was a 30-minute wash cycle, and then rinsed it out. And it did about a 90% job of what the more toxic caustic cleaner that we usually use does. So it did a really nice job, and it wasn't much change other than temperature. And I think we ran it 30 minutes instead of 20. And storage, what we got originally was in quart containers. So we just kept it in our chemical area. I'm trying to get a 5-gallon bucket because it'd definitely be much cheaper to do that.
Thanks. Vesela?
Thank you, Courtney, and thank you, Jim and all. Great presentation. I'm Vesela Veleva with the University of Massachusetts, Boston. We just got awarded from EPA funds to work with Massachusetts breweries. So Rob Vanderbilt is going to be our project manager. So we would like to learn from all of you. And my question is, because we're in a business school, so I'm going to leverage business students to help us with some of those financial and ROI calculations. I wanted to ask Jim if they did any kind of a payback, return on investment. Obviously, many of the benefits cannot be quantified easily, but just wondering if you did any kind of calculation to justify implementing the new cleaner.
I did not. We're a small brewery. There's only 2 of us that are full-time, and then we have 6 part-time people that help out. So I know it costs a little bit more, but for me, it was just, I mean, I do most of the cleaning, so I'm exposed to the chemicals all the time, and I'd like to be safe, and I want my employees to be safe. And the cost wasn't that much more for the safety.
25%.
But I have not. Yeah.
Do you think this would be a benefit if business students are able to help with that for some of the breweries?
Yes. Oh, yeah. If you could show a cost benefit, it would definitely be helpful.
Okay, thank you.
Luke, are you re-raising your hand? I forgot. Okay, yeah, go ahead.
Yeah, sorry. So yeah, I was wanting to shift gears a little bit and was curious, Jason, if so I guess back up a little bit. We've got a wastewater pre-treatment system, and we're essentially balancing our pH before we send our effluent to the Portland Water District. And we use 50% sodium hydroxide to raise the pH. And we're going through probably 300 plus gallons a month of sodium hydroxide. And I'm just curious if you've done any work or have any suggested alternatives just for the sake of raising pH in wastewater.
Yeah, that's a little out of my area of expertise, but it's a question that comes up a lot. So what is causing the pH to be as low as it is when you're doing your process? Is it from the disinfection and sanitization process?
Yeah.
Which might benefit from looking at some of the alternatives that you could use for the sanitization, where they may not be as strong as what you're currently using to get that pH back down. So you may find that if you adjust your sanitizer to some one of these other alternatives, you may not need to neutralize it because it may be close enough to where you can discharge. You'd have to look into that, but you'd find that it being a less aggressive acid and then mixing that with whatever else you had, you may be able to neutralize the cleaning bath with the acid bath and be pretty set from there. But like I said, not my area of expertise, but that's kind of one of the things that we've seen come up is if you switch the acids that you're using to sanitize, it makes it a lot easier. I know that one of the companies we worked with, they were using nitric acid to sanitize, and that's pretty severe for what they were doing. And so they switched to something like maybe pH of 5 or 6 versus a pH of 1. So you can see how that would reduce what you would need for sodium hydroxide.
Awesome, thank you.
Rob? Do you have a question?
I do, yeah. I'm not a brewer, so I'm super curious, Jim and the other brewers on in the webinar here today. So 90%, I don't like, that doesn't mean anything to me, but what does that mean to the brewers that this alternative is 90% as effective as the more caustic chemicals that were previously used? It'd be great to hear some sort of thought on that. And then I have one other question. If nobody else has another one, that I'll wait on for now.
So we base it 90%. So after the fermentation process, during fermentation, there's a large amount of foam that builds up at the top for ale yeast. So that kind of dries in a nice crust around the top. And the one we tested on, I think, was our blueberry beer. So we also have pieces of blueberry fruit that sticks and dries to the sides of the fermenter near the top. And with the alternative cleaner, it left, there was a little color discoloration and a couple small pieces. With the other caustic we use, it'll leave it shiny clean. So it was a little bit of a difference, but there wasn't enough particles left behind to make a big difference. We do a full clean about every 2 batches, and then I do a big clean about every 2 months on each fermenter, depending on how often we're brewing, summer versus winter.
Yeah, Jim specifically kind of had us come in a worst case scenario so we could see, try it on like the most difficult situation. And, maybe in the future, if it is in that kind of worst case scenario, there's the option to use maybe the more caustic option, but limit the use of caustics by using the surface cleanse in those easier situations. Okay, Rob, I think you can ask your next question.
Okay. Pardon my ignorance, but I'm curious as to whether a brewery's location makes any sort of profound difference in terms of, for example, what is the wastewater treatment capabilities? I will give the kind of obvious example for me, which is working in Massachusetts. Deer Island is a state-of-the-art, second largest wastewater treatment facility in the country, as I understand it. So how, if at all, does that play into what breweries should still be doing? And I know that that's probably a really tricky sort of topic to get into, but I'm curious, is this still impacting the environment even if a brewery is in Metro Boston and using that facility, or is that facility capable of dealing with all of this, and so it's more of an issue for other municipalities outside of Deer Island?
Yeah, that's a great question. Offhand, I don't really know. I think if we be interesting for us to check in with some of our state agency wastewater partners and get their thought. I don't know if anybody on the call has any sort of insight into that question, about whether or not it's less impactful because it's going to a state-of-the-art facility as opposed to tank out back or a smaller treatment center. I guess that's sort of what you're asking, right?
Yeah, I mean, it seems obvious to me that most people probably need to be taking some minimum precautions, and doing more like Jim is would be very beneficial. I guess I wonder if a place like the Deer Island facility is doing so much that something like this might not necessarily be worth it from that perspective, although it would still obviously be beneficial in terms of the safety concerns, which are, important too, for sure.
I think Kathy, you can speak to that, Samia.
Yes, we just recently had a meeting with our wastewater treatment group, and we were talking a bit about, the regulations and permits that are needed. And one of the things that our partner made us aware of, the pH, that low pH, it's going to erode away all of the pipes, and all of it, it damages the infrastructure. So it's not a matter of whether the wastewater treatment facility can handle it. It's all the piping in between, from your facility all the way through. And it's it eats away at the concrete, it eats away at everything. So that it's a little bit more than can the facility handle it. It's a matter of, all of the pieces. Can they handle that high pH? How long is it there? Are you going to rinse lower pH? Regular, neutral water afterwards? There are things you can do. That's why those neutralization systems are in place. So I don't know if that's really getting to what you're asking, but at least in terms of a pH issue, it definitely has more to do with the infrastructure than the actual wastewater treatment facility itself, not being able to handle it.
Okay, great, thanks, yeah.
Yeah, and if I can chime in.
Area. Yeah,
If I
please.
So yeah, you have the pH damaging the infrastructure potentially, plus the wastewater treatment facility would have to handle that as well. You also have the BOD issues, biochemical oxygen demand. And so with the brewery, you're looking at, say, a concentration of 4,000 milligrams per liter on a low end. And if you're using, so if you have chemicals, I noticed some of the stuff that showed, say, propylene glycol, that has a BOD level, which is significantly higher than like your typical household domestic waste. You're looking at a concentration of like 250 milligrams per liter. So you could really, if you're say a brewery that's in a small town with a wastewater treatment plant that can't really handle that high concentration waste, you can basically wreck their system. Whereas if you're in a place like you're mentioning, they've got the capacity to handle it, but it really matters. And it's really important for the breweries to understand who's treating their waste, and it's very different if you're on a septic system as well. But yeah, it's some, pretty powerful stuff, I guess. And, your side streaming efforts make a huge difference as well.
Yeah, thank you for that. Side streaming is definitely, it seems like that's a tough one because there's no way of getting around the expense of side streaming that I've really heard of as of yet. Is that what you have experienced as well?
It really depends. Like your spent grains, you can generally at least get those taken care of for free.
Right.
And then, yeah, some of your other stuff, you're definitely, there are some groups working to figure out some beneficial uses of some of the other side stream materials, spent yeast and whatnot for oyster feed, for example. So hopefully as the toxic use reduction conversation keeps getting more and more clear, hopefully there will be more and more alternatives for some of the waste streams to save, have it be beneficial. Anyway.
Yeah, no, that'd be great. That's a really interesting topic to think about for the future. Yeah, how to deal with the side streaming materials. Thanks.
Yeah.
Great. So we're at the 45-minute mark. Jason and Peter, do you mind dropping your emails just in the chat again in case anyone would like to follow up with you? And I'll be sending out some resources afterwards so that you can all have slides and whatnot, and sending it to those that weren't able to make it as well. Thank you all for joining this morning, and yeah, bye.
Thank you.
Thank you, guys.
Thank you.
Yeah. Bye-bye. Thank you.
All right.